So thank you for coming out here in the cold today. And before I start, I would like to tell you that this is not my work alone. I form part of the team at the university, at the anatomy department. And our leader is Professor Meyer, the crazy genius that came up with most of these ideas. So we follow suit and then just make them our own. So I'm going to start by explaining what cancer is, okay? So there are a lot of misconceptions, and after hopefully we can discuss what you might think it is, but I'll start to explain it. So, there are two main causes of cancer, one of which happens literally by a mistake, mutation. A mutation isn't like this wild X-Men thing that happens. It's just as the cell is replicating, one can acquire a mistake. The more things you do in general, the more mistakes you can do. If you do nothing and you are just standing like this, there's no chance of a mistake really, but there's no chance of anything else. The same thing happens with cell division. The other thing that may cause cancer is mutagens, so things that attack the cells. So there are cases where you have the cells, sitting quietly, yes, and doing nothing, but they can be attacked by mutagens, and a lot of these we heard of and we know, and these are confirmed, such as smoking, sunlight, and yes, processed meats. The way people have been treating cancer is in the olden times, in the old idea, it was thought, well, cancer is bad, it is one thing, you need to flush it out using chemotherapy. Eventually, they started realizing that cancers are diverse and said, okay, so let's try to treat breast cancer in this way, let's try to treat this type of cancer in this one. In this manner. However, now we realize that even within a breast cancer there can be differences, there can be different cells making up the cancer, and it can be basically a chimera, a mixture. Okay, so we have tried to use targeted therapy. Targeted therapy is one of the main things that is specifically targeting the cancer, is one of the main things that it is used, and specifically the cancer stem cells, the one that are like giving birth to more cancers. There are two major types of cancers in general. So one of them, as I was explaining, is when you have cells dividing. So cells are continuously, for example, dividing in your bone marrow. Cells are dividing when you're, for example, undergoing puberty and you have growth expansion in your bones. Okay, when you're growing, you can have more risk of, for example, osteosarcoma, because during those days your cells are dividing and growing. So this is one form of cancer, and this happens strictly by chance. Okay, as I'm saying, the cells are dividing and there is a mistake. And this mistake can happen whether you're young or whether you're old. Okay, so it can happen, unfortunately, these are cancers that will appear in children, such as leukemia, as your blood cells are forming. They can appear also when you're an adult, because blood cells are still forming when you're an adult. The other type of cancers usually affect people that are older and have been longer exposed by things of the environment. So these will affect areas like the skin that are susceptible to external effects. The colon, for example, that depending on what you're eating is being affected and being exposed to whatever you're eating. The lungs that are being exposed to what you're breathing, whether it is smoking and whether it is pollution. So these you can have a tendency, a greater tendency to get these, and this may be hereditary, your tendency, what we call predisposition, you have more chances of it happening to you, but ultimately the trigger, the final hit that gets you is, staying long in the sun, being in Australia without sunblock, basically things that are exposing you to harmful mutagens. And as I'm saying, so one type tends to be on the inside, such as your blood, your bone, your brain, which are not usually exposed to mutagens, and the others are related to the outside, affected by the outside. So let's start with internal cancers. So because of these two effects, we treat them differently, and we try to find different ways in how to attack them. So if it's internal, there's going to be one problem that happened. There's like a part that's fragile or weak in your cell, and it makes a mistake, and this mistake starts forming the cancer. So let me use a pointer over here, and one of the mistakes starts to form a cancer. And this cancer will get the advantage of multiplying much faster than your other cells, and it starts taking over. For example, in your bone marrow, where the blood cells are formed, you can have a mistake that can happen that forms leukemia, and these get the ability to multiply faster. But the mistake is one, because it happened inside you, you're not being bombarded by several several mutations or things that happen. It's an unlucky situation, it happened by chance, but it will start to multiply cells. And the more cells multiply, the greater chances of further mistakes. Okay, so you can accumulate mistakes. And even within an internal cancer, you can have different ones. But usually there is this driving mutation, the one that started it all. So, what we know as the cancer stem cell, the one that has the power to multiply and starts causing more chances of basically more cancers forming or some changes, but usually that part remains conserved. So, one way of fighting it is to attack that particular target, that capacity for it to multiply, to stop it from multiplying. And basically it's like chopping off, if you imagine this cancer growing like a tree and creating several branches. If you cut down the trunk, if you cut down that mutation that caused it to multiply, you can fight it off. And this is one way that we call differentiation therapy. Basically, rather than let it multiply, okay, we decide to give it chemicals that make it old, that age it. And very much like any one of us, unless you're Peter Pan, if you age, you will eventually die. So you stop it from its multiplying virile cell cycle that multiplies and multiplies, and we force it to age. And this, getting it out of this immortal multiplying, forcing it to age, has been known to affect the capacity to multiply. It loses its potential to multiply. So a normal cell, when it receives signal that force it to age, a process known as differentiation, will eventually die. And for example, in one type of leukemia, acute promyelocytic leukemia, there is a mutation that does not allow maturation. So it stays as a baby cell, as a stem cell, and just multiplies. Someone discovered, Hillestad in 1957, that addition of retinoic acid is vitamin A. Addition of doses, pharmacological doses of retinoic acid, helps the cancer now to mature, to overcome this immortal situation, and has led for acute promyelocytic leukemia to basically mature and eventually die. This discovery has resulted in the biggest success story of cancer to date, because before, this leukemia was over 90% fatal, and now it is over 80% curable. So it's a massive gap, in the biggest percentage gap. Okay? However, unfortunately, this is only 3% of all leukemia. So it's a rare, if you have it, you have it. at least lucky to have that type of mistake, but other leukemias will not respond to it. So what I am doing is basically finding novel chemicals that may force this to happen. And we take these from natural products. So we have products such as honey and oils that we know are beneficial against cancer. However, we especially take and also extract from the prickly pear. However, we also take items from things that are growing and maturing, such as germinating seeds. So germinating seeds have hormones that's making it grow old. So we can use that. In newt, that is, for example, regenerating a limb. So it's forming something new, it's making new cells. So we don't just throw everything at it, we select novel natural products that can affect. And we have had some good results. So we take the cells or the extracts, collect the chemicals from them, and test them on leukemia cells. However, now we're also testing on osteosarcoma, which is a bone cancer, and also on brain cancer. And so the other studies are still at their beginning, but in leukemia, this is how immature cells look, and these cells replicate very fast, and in fact, some of them are undergoing mitosis, which is cell division, so multiplying, and now these cells have been aging. So, so this is one of the good results we have, and what we seem to see is that our natural products are affecting independent of the type of leukemia. So these are actually 3 different types of leukemia, and they seem to be having an effect. There are several students and projects working on this, and so there's quite a lot of research going on, and this is just our team. And now we have moved to brain tumors and also osteosarcoma, as I said, even though we started with leukemia, so we have the best results over there. So there is one way of doing things. The other is what we do with the cancers that are external, that now have been bombarded by multiple mistakes, by several chemicals that are harmful, and now, unfortunately, you have something more akin to a banyan tree. So this tree, if you cut off the original mutation, the first trunk, it will still survive because now it has formed new cancers, okay? It has formed new mutations that drive more cancers. And usually this happens when a particular basically, the control of what keeps the cell in check is destroyed. There's a protein, known as p53, we do not need to go into it, but when that happens, all hell breaks loose, and the cancer can grow basically in any way, in an uncontrolled way. And I have a bit of an example to show you. So just to explain this, I need you to take a paper and pass on. So, and just lift the paper you get, so other people can see it. So for example, the white cells are normal cells and they are multiplying. You have a mistake, okay? And you are yellow, but it is a mistake that can be solved and the body realizes it and kills you off, okay? However, there are more severe mistakes, and those will create more lichen. And you will create more and also create new mistakes. So the color is now changing. Eventually, well, we can pause. So these are cells multiplying and they are accumulating mistakes. And the ones with color will have more of a potential to multiply. So they will override the normal cells. Eventually, if you don't mind moving, one of you will get something different. The most dangerous thing of a cancer to have, what do you think it is? Does anyone know when it comes, when they tell you, oh, now it is stage 4, metastasis. The ability to move. So you are one organ, and now you will pass that to a new organ. And you can keep on on the papers. You can take one and pass it on. So, all right, you can rest. So basically, this is what happens. And known form of targeted therapy. So let's say, if we are lifted for a bit, let's say I use a chemical that kills the orange. So the orange can put their paper down because you're dead now, but the pink, the dark red, the red, the blue, everything else will stay. Okay? So this is where targeted therapy doesn't work. Because now the blue will create more blues, the green will create more greens, etc. And unfortunately, with all of these happening like in a microevolution, one of them might get the chance to move and move to another organ. And where does that happen? That will happen, for example, in the lung, where you have a lot of blood, a lot of oxygen, so it's a perfect place for the cell to nest and start now multiplying further. So thank you very much for your assistance. So this is what we are showing, obviously with more papers and puzzles. So over here the purple started to grow, but now the purple happened, because it is multiplying much faster, has a greater chance of a mistake. And that keeps on going until you get basically what is known as genomic mayhem. So what does this mean? So you might have heard, probably you all have heard of DNA. This is the CPU of your cell. It tells you what you should be doing and how you should be working. And usually, as you are seeing, you have twice the amount of DNA. An amount that came from your mother and an amount that came from your father. So you have doubles. But in a tumor cell, everything is lost, okay? Every form of arrangement. So what you see is, you see this piece of orange that came from what was supposed to be here, but then a piece of yellow came here. So the DNA of this cell now, you cannot try to target the yellow. Okay, the yellow is bad. Let us target that yellow piece, because you have mistakes all over the place. Okay, you're just accumulating mistakes. So we need to attack this, like burn the whole tree down. Okay, so we need like a whole blunderbuss attack. But in a way, unlike chemo, at least that's the way we work, that does not attack your healthy cells. Because at the end of the day, I can kill your cancer by giving you arsenic, but you will die with it. So, there's a limit that you must specifically attack the cancer. And the biggest problem is that the cancer is your own cell that went wrong. Okay? It's not like, for example, someone gave you a virus or an infection or a bacteria and your body recognizes it as a foreign object. It's your own cell. So the biggest problem is why they use flushing out of systems like chemo that go through over to flush them out. Okay? But there should be other methods possible. And one method is the following that currently is being used. It's very expensive therapy. So just to explain, to add insult to injury, your cancer is your immune system that usually would attack bacteria, a virus, any form of infection, your immune system is blind to your cancer. But what's even worse, the cancer recruits it to protect itself. So over here, you are seeing it can get a mutation, and this mutation would be to affect your immune system in this way. So the cancer puts on a barrier, which it's your own immune system. However, this barrier was found, and one of the ways to currently treat cancer, so it's already been used, is using antibodies, things that target this particular shield. Okay? So this shield has a name, and if we attack this shield, we will switch off the cancer from protecting itself, and we can attack it. So this is one way in which we attack cancer, and that is currently in therapy. Something else that our team is working on is switching the immune system from defense to attack. So using the immune systems, and we have some good results in cell culture, switching the immune system that is protecting. So the cancer is already surrounded with the immune system, but now we give chemicals that switch off the defense and go on attack mode. And the closest thing to it will be the cancer, and hopefully it will attack the cancer. So far I have confirmed the switching mode, okay? So now we'll need to see, we're working on more research on this, and this is a form of Trojan horse, okay? Because the immune system is already next to the cancer, but what we're doing is now unleashing the attack. The third one, and the biggest one, that we're working on is creating a vaccine against the cancer. And has any one of you seen I Am Legend? Okay. I don't know if you realize, but there is a scene in the beginning where they explain how this happened, where they say they have used the measles, so basically a virus, to use it to target cancer. And this is literally what we are working on. So the idea, like, they were on the right track, but sci-fi, now, everyone is evil except Will Smith, obviously. So this is how we're testing it. And this was an idea that came to, that Professor Meyer came up with, and this was because a friend of mine had a rat pat. One of the researchers had a pet rat, and this poor pet rat had breast cancer. And obviously, my friends, there aren't a lot of solutions for rats, so he said, okay, let's put him down, okay? But Professor Meyer told him, wait, let us try something. So the rat had a cancer. I mean, it's not the rat to protect the identity of the rat. This is not the real, it's just image. But these are the cancer cells of the rat, okay? These are the actual images. And he took those cancer cells and used them as a vaccine against itself. So, for you to have for example, the chickenpox vaccine, it is that form of the chickenpox, or a weakened state of the chickenpox, to teach your body to attack it. And that's what he did, and I'll explain it in a bit. When then the cancer was dissected, it was found that it had resolved all in basically just pus. Sorry, it's just liquid material. It was disintegrated. And so basically this is done. Now we're working on, we're trying to do discussions with vets to start working on this. So far we had very few opportunities to test it, but this is how it worked. So you take the cancer of that dog, okay? So what you're going to form is going to be specific to that dog, not to anyone else. You can't use it to vaccinate anyone else, and modify the proteins. So you kill the cancer off, but keep the ingredients that make it, so to speak. So first and foremost, you give the dog a normal vaccine. And dogs, for example, have the 7-in-1 vaccine. So in humans, this could be like the herpes zoster, okay, the chickenpox, okay, and you're going to have it. So you will train your body to attack this, whatever is in it. So if it's a chickenpox vaccine, it will attack the chickenpox. In this case, these 7-in-1 viruses. Next time, with this virus, you insert pieces, fragments, ingredients that make up the cancer. And you inject it together with your 7-in-1 vaccine. So first, you taught your body to fight against, let's say, chickenpox, okay? Next time, you give it chickenpox plus some ingredients from your cancer. And now, because the body already knows that it needs to attack chickenpox because it's bad, it will attack also the cancer ingredients, okay, the cancer fragments. And this way, you are teaching your immune system to attack the cancer. And from then on, your own immune system will result in attacking the cancer cells. Your own cancer, so this very specialized treatment. And we've had so a few graphic images are coming, so if you'd rather not look or look down. So we had a dog that had sarcoma, and as you can see, he had a tumor on his leg, and over time, this tumor completely reduced, okay, vanished. So it has worked. In some cases, his own body has learned to attack the cancer. We also had we had also a dog, a Chihuahua with melanoma, and as you can see, it was severely reduced. Okay, so we would like anyone that for some reason has a pet, or you know of someone that might have an animal, a pet that has cancer, and the vet would like to put him down. We wouldn't mind recruiting anyone. We are not telling you we're experimenting on it, but if there's no other hope, why not try to use it? Because we cannot go to clinical trials before we get more data. Okay, so hopefully this also happens to, we can use it on humans, but it is far way off. These are all our basically sponsors and collaborators, and this is our team. So it's quite a lot of people working on these. Thank you. Thank you very much.